Today I'd like to take a look at graphing numerical data again. We're going to be taking a look at histograms and ogives. Now let's begin with histograms. When dealing with numerical data sets that happen to be large, a histogram is probably a good choice. Histograms can be used for both discrete and continuous numerical data sets. Now remember earlier when we talked about smaller sized data sets or medium sized data sets, then we were taking a look at possibly using dot plots or stem and leaf plots, but when our data sets become quite large in nature, histograms are usually the best choice for making this graphical display. When creating a histogram, it's necessary to begin first of all with a frequency or a relative frequency chart. Remember, a frequency chart basically is the counts of our data in certain categories, and the relative frequency is the percentages of our data that occur within our basic categories. Now, histograms are similar to the bar charts we constructed using categorical data. However, the bars are actually connected in a histogram, and the width of the bar is actually determined by the person creating the graphical display. So once again, histograms look similar to bar charts. However, histograms are used with numerical data. Bar charts are used with categorical data. In histograms, the bars are connected, and in bar charts or bar graphs, the bars are not connected. Once the histogram is actually graphed, then we can start talking about the certain features of the distribution that are going to become important to us. For instance, center, shape, spread, unusual occurrences. And once again, we'll really focus on those in a later section. But histograms are a great way of displaying numerical data when our data sets happen to be quite large in nature. Now, because the interval length is determined by the individual creating the histogram, there's some subjectivity in its creation. There's not necessarily a rule of thumb method to create a histogram in one particular way. So histograms often may look different from individual to individual, and it's all based upon the individual's determination on how they want to set what we call the interval length or the bin width. So not everyone's histogram will look the same for a particular set of data. However, if the guidelines are followed for choosing the width of the interval, or what we call sometimes the bin length for the histogram, then the results should reveal basically the same features. So although they may be a little bit different, we're going to see the same trends occurring when we talk about the features of our distribution when a histogram is created. Probably the biggest advantage in constructing histograms is its ability to handle large amounts of data in a graphical display. It's also easy to compare data using comparative displays as well. One disadvantage to the histograms is that the actual values within the data set are not retained since they're grouped together in intervals. Appearances in graphical displays may also be different since there is some subjectivity in its creation. So overall, the biggest advantage is that we can use this when we're just trying to display graphical displays of large data sets. But once again, the disadvantage is that it doesn't retain its data values. It basically groups them together in what we call intervals or bins. Now, when working with discrete numerical data, the frequency and the relative frequency charts we create for use in the construction of a histogram is similar to the ones we created using categorical data. Let's consider the following example. Suppose each day an auto mechanic recorded the number of cars needing an oil change over a 30-day period. So basically we have number of cars needing an oil change over a 30-day period, and we see that we had 0 cars needing an oil change occurred 4 times. There was 10 days we actually had 1 car needing an oil change. On 8 particular days we had 2 cars needing an oil change, and on 3 particular days we had 3 cars needing an oil change, and on 2 particular days we had 4 cars needing an oil change, and on 3 days there were actually 5 cars needing an oil change. So if we sum up the frequency, that's going to total that 30-day period, and that basically represents the frequency of the number of cars needing or requiring an oil change. And we can convert those frequencies or counts to relative frequencies by taking the frequency divided by the total number of days in this case, which is 30. So 13.3% of the time of the days over a 30-day period, we